Hi there, this is Dr. John, and we are closing in on the end of our review of geometric sequences and series. I've got 3 short answer questions for you here, the kind that might appear on your exam. First of all, what type of sequence is this? 0.0005, 0.005, 0.05, and it continues on. Well, this first of all is a geometric sequence, so the answer would be geometric series sequence. It's not a sum, so it's just a sequence. Geometric sequence with a first term with t1 is equaling to 0.0005 and the common ratio, since we're going up by 10 each time, equaling 10. Because it has a common ratio for each of them, it's a geometric sequence. That's all you would need to do for that first one. Let's take a look at the second one. I'm going to erase this here. For the second one here, they want us to find an explicit formula. An explicit formula is one that is easy to plug in the values for n. I'm going to show you how to derive that for the general term and find T11 for T1 is equal to 3. So the question is T1 is equal to 3 and the common ratio is equal to 2. So we've already determined that it's a geometric sequence and we want to find a general formula for that. If you remember how the nth term looked, it looked like this. We had the first term, or a for some people, times the common ratio n minus 1. So T1 here is equal to 3. The common ratio is 2. And then n minus 1. We can sort of pull this apart if we want to, because this is the same as, we give some space here, this is the same as taking a 2 in the denominator with this. So we start off with this 3 here, or we could put a 2 under there because of this, and then we have 2 to the n. And we want to find a specific term. We want to find out the 11th term. So let's take a look at that up there. It's going to be 3 halves. You don't have to pull this 2 out like I did. 2 to the 11. I am getting 3,072. Seems like a reasonable number. 2 to the 11 should be a fairly big number. I hope that helps. I'm going to erase this and we're going to look at this third one here for a second. For this third one, we want to do the same thing as here. We want to also find an explicit expression formula for the general term, only this time we are using this here, not this. This was for question 2, but we're doing the same thing. I just didn't want to rewrite the whole thing out again. So the first term here, T1, would be equal to 3. Easy enough. What are we multiplying the second term by? The common ratio is root 3. The common ratio doesn't have to be just simply a 1, 2, 3 or a fraction 1/2, 1/4. It could be a radical, could be pi, it could be many different things. So here we have these things. Let's check this out. If we take root 3 times this, the root 3 will make this into another 3. Root 3 times root 3 is 3, times 3 is 9, and the same thing over here. So it works for all of them. This here, we've got this now. Now let's write this in general terms. It will be t to the n is equal to the first term, 3 times root 3 is the common ratio, and we want this to the n minus 1. Now that's probably the way that I would just leave it for now. You could take out one of the root 3's, put it over here. You'll still have a root over here. I'm not sure if that makes it easier or not. Let's just use this formula here. Now we'll want to find this value to the 11th. So we want to find t to the 11th. The 11th term in this. It's going to keep on going. Let's just take a look at it here. We're going to have 3, that's this first term, and then it's root 3 to the 11 minus 1, or to the 10. And that we can simplify a little bit because you have a square root here. Let me just write this all out. It's equal to 3, and I'm going to make this bigger brackets over here. Square root of 3 squared to the 5. These two would be to the 10th. I've just pulled these in here so you can see I took the square root, I squared it, so I get rid of that. I just simply have a 3. So I've reduced this number on the outside here. So it's 3 times 3 to the 5. Well, we could pull this in here, make this 3 to the 6. I am getting 729. There's your answer for the third one. I hope that helped with our short answer ones. Last section, we're going to do a couple of longer answer ones for geometric sequences and series. I'll see you there. Bye-bye.